Well, let's get started. I'm not surprised. It was very quiet. There were very few students here.
Maybe.
As I said, the Den-en-toshi
The train.
is not running. It's not running. So there may be many, many people.
Yeah, I think it's because I had a first class, so I was here. So I could get
Right.
remember. Maybe the other picture.
Watanabe-san lives in Yoga, so he can't get here.
Oh.
So he's on the Den-en-toshi. So he can't come. He won't be able to make it. So I'm trying to think how to, because you've seen this. You've seen this.
Yeah.
I want them to understand. So you know what I'll do? I'll do this. Well, let's see. What's the right thing to do here? Let me do this when they're here.
Okay.
I want to do that when they're here. So what I'm going to do is I'm going to get. Now I've asked you to do this. Have you seen the Alibaba? Have you had a chance? Have you been able to the Alibaba site? It's a very good. I think this is a very good exercise.
But I feel like most of the products are made in China.
Right. It's most of it's made in China, but excuse me. But what that really means, much of the world's manufacturing is in China. A lot of the world's there's many products. I mean, Japan manufactures like automobiles, finished products, very high value, like steel, high value metal. The manufacturing here is high value. Your standard mid-price, mid-value manufacturing, much of the world's of that in the world is now done in China. That's why, of course, Alibaba is a Chinese site, and they're trying to promote Chinese business. But I think it's a good example because you'll be able to. What I'd like you to do is you get like the factory address. Make sure you get the factory address. That's very important. If you have the factory address, then that's where you manufacture, and that's where you want to see where the manufacturing takes place and map out. And one of the things you'll see is that for many products, you'll find that many of the products are made in one city. If you have a very specific product, you'll find it's in one or two cities. So you'll see that, as I say, it's probably in China. And for the students that aren't here now, you'll want to check that and look. I think the best way to do it is to go to the foreigntrade.com website, pick a 4-digit or 6-digit, so you can see what the name is, and then go to that product and go to the Alibaba website, and then see where the companies that manufacture that product are located. And then what you want to do is, once you get that list, you'll see whether they're in one city or maybe one or two cities, and then go and check and see, does China dominate the manufacturing in that specific product? So that's what the exercise is for, to see the evidence of increasing returns to scale. So this is a way to show that there's increasing returns to scale just by using information that you can get on the internet.
So after I go to Alibaba, I check if China is dominant or not on the.
Right. What you want to do is pick a 4-digit or a 6-digit product. Then go to Alibaba, type that product, see the companies that sell it. You can get a lot of information. It's very easy. Of course, you'll get the company name. It'll tell usually the province, but and make sure you get the factory address. It'll tell the company size. Sometimes it'll tell you the size of the manufacturing plant, because customers want to know how big is your plant. Because if they want to order a large number of goods, then they'll want to know, is the facility big enough that if a company makes a big order, that whether they can fill the order. So that can be important. You'll want to see the year established, because probably the newer the company or the newer the industry, it's probably more that they're more in one place. So then I'd like you to use PowerPoint and Google Maps and just plot the location of the factories. And you'll probably see there in many cases, many industries, you'll see that it's in one city and even in one area in a city. So that is that's the assignment. That's what I want you to do. And please contact me if you have any problems. As you see, that's the it's a wonderful site. It's really a wonderful site. And as I say, for those students that aren't here, I'll be uploading this to the web, so you'll be able to watch the lecture. I understand it's not a very good day today, and some of the trains aren't working, so I understand why you're not here. We're going to have the discussion on the trade surplus and the GDP identity, the macroeconomic identities. I'll go over that later when the other students are in the class. So we'll talk about that. But what I want to what I'm trying to do is present you information that talks about talks about how to think about the various ways that you can think about how the world works, and what we're going to talk about. So that was to understand how the world's connected. So how the world is connected through trade, through financial, through capital flows, trade flows, as well, of course, as migration. So all of the various ways that the people around the world are economically connected. What I'm going to talk about today is introduce the idea of how people are connected and how we're connected across time. And when I mean that is when we talk about technological transformation, we talk about change and technological change and how economies change. So economies change over time, and and that's done through technology, what we call technology transformation, technology change. And those play a very big role. And one of the ideas that I'm going to talk about is the idea of how economies change over over time with technology. And one of the ideas, I'll talk more about the specific economist that's done this. It's a Russian economist called Kondratiev. And he came up, it was earlier in the 20th century, he came up with the idea that there were long waves of change. He noticed that he could see that there were patterns of technological change, and how those technology changes then went into the manufacturing process. They became part of the economy. And they increased productivity, and then productivity growth begins to slow, and eventually a new technology comes up. So his idea was you get a new technology, it comes up, it peaks, it goes down, and then another technology comes into place, and to replace that technology. So that's what we're going to talk about. And one of the very interesting things that he noticed was was that he noticed that these cycles, these economic cycles, seem to last about 70 to 80 years. That these periods lasted about 70 to 80 years. And so one of the things that I want you to make you aware of is how these changes take place. And early, the first one that I'll just very briefly talk about, it's not central to the story today, but it was the introduction of the steam engine. So the steam engine was the first major machine that could do mechanical work. There were steam engines that were invented in the early 18th century, in about 1712. But the real major advancement in the steam engine occurred in 1781. So with the patent by James Watt of his steam engine, which had an increased capability to create power. So if we take about 80 years, 70 to 80 years, then we get about 1850 to 1860. So 1850 to 1860. So then what happened then? And I think I talked a bit about this last semester. You had the discovery of electricity in the late 18th century. Then in the 19th century was about understanding, there were many discoveries about electricity that were made. And the first real use of electricity that had a big technological impact was the telegraph. So the telegraph came about 1850. So about 1850, you had the steam engine, and the telegraph, so the use of electricity. And then electricity itself began being used in manufacturing. So another 80 years was 1930 to 1940. So in that era was the use of electricity in manufacturing, where the steam engine was used to turn things and was used to create mechanical power, which was then used in manufacturing. And then electricity, electrical motors took that place in the 1930s. And then, of course, but that process went back some decades. In the late 19th century that was introduced, but it was not until this era that began to have a big impact. So then we go another 70 to 80 years ahead, and that's 2010 to 2020. So that's the era we're in right now, is 2010 to 2020, and now we're seeing again another use of electricity, and now the use of electricity in computing to do mental work. First to do steam engine to do mechanical work, electricity to do mechanical work, and now electricity to do mental work. Now around that we've also had the effect of one of the things we're going to talk about is that we've had great financial crises, and great financial crises of the 1930s and the 2000, from about 1929 to about 1940, and we've had the financial crisis from about 2007, 2008, and we're probably coming to the end of it. Now the interesting thing again, what's 80 years on that? 1929 plus 80, it's 2009. So it's really, this idea about these 80-year cycles, that these, we've seen, and what we'll talk about is how these financial crises are related to technological transformation. And in the way that they're related is that people tend to get really excited about new inventions. And they see that a new invention is coming, but what happens is they put too great a value too soon on the value of the technology. And that's the story that we're going to say. We're going to talk about the technological transformation and how in terms of how it changes economies, but also in terms of financial crises, the connection between technological transformation and financial crises is that people get very excited. They get very excited about the technical change. They begin to think that the technical change is going to have an impact sooner than it does. And so that they tend to, what we saw both in the 1920s and in the 2000s was that asset prices rose greater than was justified by the actual valuation, because people thought that these technological changes were going to come sooner than they actually did. So that's the basic story that we're going to say. We're going to talk about today. And to start, we'll talk about the shift. I mentioned the steam engine. The steam engine that was in the big enhancement that was made in 1780s, 1781 was the patent by James Watt. This was what the steam engine was used for. This was manufacturing in the late 19th. This is what manufacturing looked like in the late 19th century. This is what, if you went into a production plant, if you went into a production plant in about this is probably about 1890, this photograph is somewhere probably about 1890 that it was taken. And these are workers that are working on a production line in the late 19th century. This would have been considered very modern. This was a very modern production facility. And if you can imagine 100 years earlier, this was 1,000 times more productive than what people could do 100 years before that. So this may look primitive to us, but this was quite technologically advanced at the time. And what the system was, it was called the line shaft system. So it was a shaft, this shaft right in there, and the shaft was powered by steam engine. So it was powered by an engine that drove the shaft, and you had the shaft, you had what was called a counter shaft, that then the turning, the energy from the turning was transmitted by a belt. So the belt that's coming down right there, and it spun. And it had various speeds, so then it could change to various speeds that it could turn, and people could machine. They did machining, machining tools. And it spun this, what was called a driving spindle, and then people would, it spun, say you had a grinder, or so you could grind tools, for example. You could work metal. So that's what. So you had these individual craft. So people did this in order to in order to manufacture. So this was an important part of the manufacturing process. Now, what was interesting is you can see there's all of this. There's a lot of infrastructure that's required. Here's this factory. All of these belts. All of this, these shafts are spinning, and one of the things is that in order, even if, no matter how many people are, one of the problems with this was that no matter how many people are working, it has to spin. So it basically had to spin for the entire factory. So the entire factory floor had to be driven. So whether or not people were working, you had to have it, even if one person, in order for one person to work, everything had to be running. So it's not a very efficient, it's an inefficient way to do work. But you can see how it comes down, and then you can see there, that's the what's called the driving spindle there, and then he's trying to do some kind of machining. This fellow here is trying to do some machining. You can actually see the machining work that they're doing there. But you can see all of these pipes. There's a lot of pipes. It required a lot of grease. A lot of oil. Everything is spinning. A lot of oil. It was very dirty. So you have oil everywhere. It gets dirty. It's a dirty. The grease and oil gets everywhere. You also have fire hazard. So these factories had a greater fire hazard. They also had to be. These buildings had to be the roof had to be very strongly built. So the factory, these roofs had to be heavy enough to carry the weight, all of this weight. So it was very complicated, costly type of manufacturing. It was very efficient for the time. It was very it was much more efficient than what came earlier. But we can see now there were a lot of problems with it. If the machine broke down, all you had to do is one little thing goes wrong. One thing goes wrong, the entire line stops. Everything stops until it gets fixed. So you're going to have a downtime. There's a lot of downtime in the manufacturing. It's a dirty environment. It's a somewhat dangerous environment. It's expensive to build the buildings because there's all of this infrastructure. The buildings have to be very strong. It costs more to build the buildings. It was an expensive, at least compared with future manufacturing, with using the electric motors. It was a less efficient way to do things. So this began to change. As I say, this probably was about the 1890 or so when this photo was taken. And you can find this online if you just put that in. You'll get this photograph. That's what the reference is for. If you're interested in looking at it yourself on the internet. But even by then, you had the electricity had been understood. More and more knowledge about what electricity was and how to, what we say in English, to harness it, to use it in order to create mechanical power. The first real electric motors that were practical, that could be used in manufacturing, were developed about 1880. So around the 1880s, you began getting manufactured electricity. This was also, the 1880 was the same time that you had the development of the electric light, was about 1880 by Thomas Edison, United States. So you started in New York around 1880, started getting electric lights on the streets. So that was the first beginnings of electricity. Edison also started the world's first electric power plant in New York in the 1880s. It was a coal-fired power plant. So this power was powered by typically water or steam, the steam engine, but it typically needed quite often access to water or to some power source where you could get water to the machines that drove this. So around 1880, you began to get the first development of electrical motors. Now, what was different about an electrical motor, and people realized right away, well, if you have an electrical motor, you can hook the motor up to a machine or to a few machines, rather than to have the whole plant being driven by the line shaft. So that's the advantage. The problem was that the early machines had very little power. There were very little power. They didn't have enough power to power these, and they were big. So the early electric machines were relatively large. They didn't have. They weren't very efficient. They couldn't. And of course, they were expensive. So it took a long time in order for the electric motors to get more powerful, to become more efficient. This was a slow process that took place over the 40-year period from 1880 to 1920. Now, one of the very interesting things is that what we're going to show is that 1880 you have the beginnings of the development of the electric motor. About 1940, you have the beginnings of the computer. So 1940, the computer, so over a 40-year period, over that 60-year period, the computer developed, and to what we have now. Well, the very similar thing happened with the development of the electric motor and the use of electricity in manufacturing. 1880 to 1920, you're getting an increase in that, and I'll show. Let me get another. I'm going to go to another paper, and I'll have you. I'd like you to read this. This is a very interesting paper that talks about the shift from the drive shaft. From drive shaft to electrical wires, and so he talks about the historical perspective on electrification. You can see this was an article written in 1930. And these are one of these fascinating. This is economic history. I think economic history is a very interesting topic because people can go and go back and look and see the way changes take place in an economy. And he's talking about he's talking about the productivity in see, he talks here. It's 1890. He's got data from about 1890, 1900. And here's he's showing indications of change in energy use and how energy. So in this 1890, 1900, 1910, there was an increase in the use of energy. There was an increased use of energy, which meant there was an increase in inefficiency. The electric motor was introduced. He's showing here the energy consumption. He used the gross national product. It's similar to gross domestic product. We tend to use gross domestic product now. So it's a very slight difference in what the figures are. But he shows, this is in the United States, the energy consumption and gross national product, and energy divided by gross national product, and he shows how this number rising to 1920 shows it was decreasing productivity. What was happening was people were beginning to change to electric motors, but they weren't very productive. It actually didn't increase productivity. The important lesson there, and the very interesting thing is that this process, if we had lived back then, we would have said, we've had the line shaft. It's worked for many decades. It's done okay. And they're trying to put electric motors, and they're using more electric motors, more and more, but productivity is not rising. So we're saying productivity is not rising. This is very similar to what happened with the use of the computer. The use of the computer, 1950s, 1960s, 1970s, there's more and more use of the computer. The computers are getting big, more efficient, they're getting better, but productivity didn't rise. The very same thing happened with the introduction of computers, that you had more computers, more consumption of computers, and yet productivity did not improve. So we saw a very similar thing. That's something that we've seen in the past 40 years with computers, and now that's beginning to change. And what he's showing here is this process that happened with the use of electric motors and with the use of electricity in manufacturing. So I want to alert you to the very, very similar process that goes on. He shows here, that's a reduction in productivity. Then, after 1920, there's the big change. See this? 1920 to 1930. And that's when people thought, oh, okay, everything's going to change. The whole economy's going to change. It's going to change right away. It's going to change right away, and we're all going to become very wealthy right away. This was the boom of the 1920s. The boom of the 1920s will show the boom in the stock market. There was an economic boom, but it was more a boom in the stock market that people saw this and said, okay, it's ready right now. But it really wasn't until the 1950s that the technology really took place.
So the graph shows the reduction in productivity, or
this is energy divided by output. So economic output. So that says you had to use more and more energy in order to get the same for each unit of output. So that's a reduction in efficiency. So this is saying that as your output is falling, that you need less energy to produce the same units of output. So 90 to 60, that means that it's 1/3 less energy for the same output.
it's more efficient.
It's more efficient. Yeah, this means the lower the number, the more efficiency. The higher the number, the more inefficiency. So this is a very important chart that shows that. And as I say, you can see 1920s, from 1920 to 1930, a huge increase in productivity. And one of the things that, so that was when you had the boom, and we'll show a little bit later, the boom in the stock market that took place in the 1920s. And basically what happened was people saw this, and they said, it's going to happen now. And one of the things that we'll see much later, I just want to talk a little bit about this story now. The 1990s was the same thing. Now, you were too young to remember, but the 1990s, people thought computers were going to take over right then. People thought the internet was introduced in the 1990s. Computing became much more powerful. People thought, it's now, it's happening right now. And the same kind of boom that you had in the 1990s as you had in the 1920s. In terms of that, or at least what people thought was the increase in, they saw increases in efficiency and they thought it was ready to happen right now. And we can see here, the labor, there was the increase in labor productivity, but not in capital productivity. He showed it does not happen in capital productivity until later. Capital productivity finally, see, 1900, and almost 1940, capital productivity was not much greater. It was not until the 1950s, and again, we see that was how long it took. And this shows the share of steam engines. Here's 1910. So it was the year, in the period between 1910 and 1920, how electric motors, how they started, see in 1900, even by 1900, very low. See, water was still used in 1900. It fell off very, it was declining, but steam engine in 1900 was 80%. 80% of the mechanical drive, 80% of the mechanical drive that we showed in the line shaft to drive came from steam engines in 1900. Virtually zero from electric motors. Just a very low percentage, just a few percentage in 1900. But it very rapidly, 1910 it went to 20%. 1920, by 1920 it had passed. 1920, electric motors had passed the use of steam engine in driving mechanical drives. And also, here is the power capacity. Another thing that changed, as you say, you had the production. The interesting thing was, in terms of electricity, you had the production of electricity became more centralized. You had more powerful power plants, so you had an increasing returns to scale with power plants. So the power plants got bigger. That became central. The production of power became centralized in centralized power plants, and at the same, but the miniaturization of the electric motor, the motors got smaller and more powerful. Just think about how with the computers, smaller and more powerful. Well, electric motors, the same thing. They got smaller and they got more powerful, and so that they could do more work with less energy. So that was the process that went on. So he talks about here this line shaft, the same thing as what I introduced in the picture. So he goes through and talks about that. This is as I say, this is a very I think this is to get a historical sense of this and really to understand the effect of technology. I think this is a wonderful article, a wonderful piece of work to read about this. So let me get back to this story. As I mentioned, and this is again another late 19th century. And this was another use. You can see it wasn't just that you had the workers on the line there. This was another use. Again, they're driving. This is piping and gears. So they're making, and you have this pulley, the pulleys that's moving this heavy machinery around. So again, very typical late 19th century. I think this was of a plant in either France or Switzerland. So this was a European example. I think the former one was American example. But as I say, the line shaft system, direct mechanical link to power sources, water or steam, large friction losses, so very inefficient. As I mentioned earlier, rotated regardless of the number of machines being used. The breakdown in either power unit or the line shaft caused a breakdown in the entire room of machines. It required a large number of machinery operators. Oilers. And this is a point I didn't make. Very little flexibility. Once the plant was constructed, and you have all of that infrastructure in place, that's the way you're going to manufacture. That's it. It's you can't change. You can't change that system. What the motors did, the electric motor did, was it enabled everything to become more miniaturized, and it made manufacturing much more flexible, which of course led in the early 20th century to the production line, the development of the production line in the production of automobiles in Detroit after 1910 on the Ford motor, the use of the production line. Well, that was the use of that was helped by the use of electricity. You couldn't do that kind of manufacturing with this kind of system. This system has all of this infrastructure. So once you plant the plant constructed, you can't change it. A lot of infrastructure required, and so you can't create an assembly line. The assembly line that became a part of manufacturing in the 20th century, that was something you could not do. You needed the development of electric motors in order to do that. So I mentioned the shift from steam to manufacturing. I want to talk about that. The coal and water power. The coal to heat water. So the steam engine. You either used flowing water and you used the power of flowing water to create mechanical energy, or you used the steam engine, which was heated. You heated the water with coal. So this was what we call the use of raw energy forms to the use of processed energy, the internal combustion fuel and electricity. So that was the change that took place. What we're talking about are the changes that took place between 1880 and 1920. So the processed energy forms produce increased thermal efficiency. So the thermal efficiency is the ratio between the useful output of a device and the input in energy form. So there's less energy input that's needed in order to create useful work. And the reason is that the kinds of fuels that were used, natural gas, internal combustion fuel, electricity, were greater thermal efficiency than the use of the raw energy forms. But as I say, the very important thing and we've noticed in the statistics, it did not immediately affect the use of the line shaft system, and it required a long time to make the transition. And one of the reasons, once you built it, you have to. The investment is made. You have the sunk cost. It's your capital cost. It's your fixed cost. You have to use the plant until it becomes obsolete. So you have to get use out of it. So once it's built, it's going to operate for 20, 30, 40 years. So until it gets to the end of its life, you're going to be using that technology, even if a new technology comes into place. Now, as I mentioned the 1880 because that was when, around 1880, was the electric motors were improved. The first use of electricity was reportedly used in 1883. The 1890s, they were becoming commonplace. They were becoming more common in manufacturing, but the power output was low. The power output was low. So the 1890s, as I noted, by 1900 it was still mostly steam, the steam energy. So even in the 1890s. This was a very important development. As electricity grew, the plants were separated from the power sources, especially water sources. In the late 19th century, power plants had to be located somewhere near water. They had to have water, either a river, some type of river, flowing water, some type of So with the use of electricity, you could begin to move plants to locations where perhaps more people lived, where it was closer to consumers. So in locations that were more that could be more efficient for production. but the steam engines were replaced by electric motors, but the motors still were driving the line shafts. So the line shaft use was still, so electricity was used to transport mechanical power to the factories, not to distribute power within the factories. The motor, the use of the motor within the factories was, that's this change, to distribute power within the factories, which is what enables you to get the assembly line. As I mentioned, the technological advance was smaller engines, smaller electric engines, and more powerful. So you could drive, instead of the line shaft with the whole factory floor, you could start breaking up the production, smaller groups that were driven by an electric power. So if you had a problem with one motor, well, everybody else can keep on working. It's just one small area, and it's more efficient. It's more specific to whatever you're trying to do in an area. Whereas with the line, and this was called group drive. So group drive, you were able to get people into groups, smaller groups, rather than the line shaft, which was the entire floor. You were getting people into smaller groups that could work more closely together in more specific aspects of manufacturing. One of the things was, I mentioned the counter shaft. Let's see. So there was the counter shaft was the first thing. This was eliminated. Then they just have the direct. They started having just a direct shaft. And so the production machinery was belted directly to the line shaft. So now it's getting more miniaturized. Think about it in terms of computing. The computer's getting smaller. The machines are getting smaller. They're getting, instead of a whole factory floor, it's beginning to break up. Now here's an interesting point: was that even in the 1890s, or even in the first decade of the 20th century, that electricity was still primarily generated within, the power plants had to generate their own electricity. The idea of going and this electricity comes from a power plant somewhere, we don't even know where. I don't know where it comes from. It's somewhere probably up in the mountains. There's some hydroelectric power. There's some coal-fired power plants. There's some other different power plants. Used to have nuclear. There's probably not much nuclear now. So those are but it's somewhere out there. Where in this era, it was the electricity was generated at the plant. You had to have an electric. And here was an interesting point, and this is one of the reasons why it took a long time. That energy costs were not an important part of the overall production costs. So when energy costs were not an important part, the driver of innovations was not energy savings, and this is one of the things that delayed the advantage was that when you broke it up, you could make more efficient manufacturing. But the problem was that people didn't know what to do. It wasn't until they realized, okay, well, we can break this up. It took a long time to realize how that could change the way they made things. People don't just change overnight. There's and in the same way, computers have been around for a long time. We've had, since the 1980s, we've had personal Personal computers came in the 1980s. It's only, the internet came in the 1990s. But we're still just now really beginning to learn how to use the computer, and the internet in order to make things. That's just beginning to do. So these technologies take time. They take time. So as I say, but the firms began to isolate the production of energy from the use of energy. As I say, the power plants got bigger. They moved away from the factory. They got more efficient, so they got bigger. You could produce more electricity. Then you had these improvements. And one of the things that it led to smaller on-site power plants and lighter factory buildings. So the factory buildings could become, if you've seen buildings, factory buildings in the late 19th century, you don't have those in this country. I don't think there's anywhere you'd have a late 19th century. But in the U.S. you still do. You can go to older cities, particularly in the eastern part of the country, and you'll see buildings that were built in the late 19th century, and these very big, heavy buildings, much lighter construction, that you could build factories that had much lighter factory buildings. That means you could build the buildings were cheaper, you could build them more quickly, it cost less to maintain them, they were cleaner. They were cleaner than the old buildings with the line shaft. They had a lower fire risk, so it was healthier for people to work there. The roofs were no longer needed to support the heavy line shafts, the counter shafts, and the pulleys, so the roofs could get taller, so you could have more space. So the factories just so all of this began to change in the early. Especially in the early 20th century. So as I say, these things take time. And again, think about the computer. How the computer, people had them, they used them kind of as calculators. People use computers as calculators for a long time. It took a long time to figure out, well, how do we use these in order to actually improve the efficiency? And things like Excel, then you could begin to create databases. But then eventually you begin we're now learning how to use them to make manufacturing more productive. The same thing, early 20th century, that manufacturers began to realize indirect savings. Indirect savings were the indirect savings. How do I say it? Let's go back here. Again, this kind of production is very rigid. What they mean by indirect savings is that when you have a power plant, when you can rearrange production, when you can change the way production is made, you have the flexibility in designing buildings, to arrange the machinery. So you build a building, you don't really worry about how you're going to use it. You build the space, and then you figure out how to use it within the space. So you made the machinery could be arranged according to a natural sequence of manufacturing operations. So you have some part, you make one part, that goes to make another part, that goes into a third part, and it's all used to make some product, like the automobile. And that was the thing. The automobile, you created the assembly line, and you had workers, they got a piece, they put the piece on, then they put the next piece on, the car went down, and people machined, and it was all done in real time. You could not do that before. You'd have to make the part, take it somewhere else, put it together in one place. Very inefficient. So that was the idea, was that the natural sequence. That was it. And manufacturers realized, oh, we can do this to make a natural sequence. And once you start making a natural sequence, that's the first step. You're making all the space equally useful, the first step in assembly line production. As I say, it increased working space per unit of factory space, and more space in the third dimension, up and down. So as I say, the roofs, you had higher roofs, you didn't have to worry. With the line shaft, the roof had to be very low. So it's a low roof, so here now you could have lift up product, you could have it come, you can use the third dimension, so you can just have things come from above, whatever direction that you can just picture it. It was much more efficient way to do things. But you can imagine, if you were used to the line shaft, it would take time. It would take time in order to do that. As I mentioned, there was better lighting, healthier, it was cleaner, where once, for example, where do you put, look how dark that is. Where do you put lights? Well, you didn't really have much electric lights anyway. You didn't really have, the first electric lights were just being developed. So you had to use natural light, but where does the natural light come from? There's no, it's a very dark working environment. So you can construct lights. It's more light. It's a more comfortable working environment. As I mentioned about a dramatic reduction in the use of oils, so grease-laden dust was reduced. Cleaner. The facilities were cleaner. They were better places to work. So this was the way that electricity created gains in efficiency in the rearranging of production. That's the thing, the rearranging of production. And in the same way, that's what manufacturers are just now beginning to understand. How do we use computers in order to make production more efficient? But one last thing was that motors and tools, that the use of motors to drive tools, actually to drive tools to use to do fine machinery, people were still use the tools. The motors were not driving the tools yet. So and again, you can see these things take a long time. A long time to develop, and that's the point I want to make. And when we compare the development of the computers, because that's something that we're familiar with in the era. I'm older than you, of course, but you've seen in your lifetime the expansion in the use of computers. So 1909 to 1919, very important time. Now we talked, of course, that was the First World War in Europe. Europe was devastated, but the United States was fine. The United States, they sent troops to the war, World War I in 1917, but came out of it a stronger country. And I suppose, I would suspect Japan was the same way. Japan was not touched by World War I. Japan had its war with Russia in 1905, and Japan had emerged as an important power as a result of the Russian-Japanese War in 1905. So Japan, probably also Japan was a major was not significantly affected by World War I. So in that decade, the United States is moving forward, and probably Japan is as well. So in this decade, there's the big changes that are taking place in that 1909 to 1919 period. In 1909, 64% of motor capacity was powered by on-site electricity. By 1919, 57% of motor capacity was generated off-site. So it was the movement, instead of on the site, it was off-site. The similar thing that we'll see later, so we have 1909, remember this happens in the 1920s. So 1920s, we see the stock market boom. So 1909 to 1919, we see this, the dramatic change in electricity supply. We see the emergence of the change in manufacturing to the assembly line, your use of the assembly line, and this is the expansion of electric utilities in the 1910s. What happens in the 1980s? 1980 to 1990 in computers, personal computer. Do you know what a mainframe? Does a mainframe computer mean anything to you? Yes, it's something. It probably doesn't mean anything. A mainframe computer. When I was, as I say, when I was an undergraduate, the first PCs, personal computers came out at the end of my undergraduate. We had to use mainframe computers, and those are big computers, central computers, and you would send work to the computer. And I can still remember where you had workers that had cards, like paper cards that were punched, and you punched the card, and it sent the instruction to the computer. It was done.
Is it like typewriter or something?
Typewriter. Well, you probably, yeah, you'd use that to punch the instruction, but it was put on a paper card, like a card, and that was input, and so that was how you told you gave instructions. It was part of the software of the computer. But the thing was that they were run by these big mainframe computers. This is the same thing. This shift in 1919 was the shift in motor capacity from on-site to off-site. Whereas in this era, it was the beginning of the use of personal computers. So electrical generation technology changed. That this was here's the interesting, the alternating current. There's DC and AC. I'm not an engineer, but I know what DC and AC, alternating current and they used DC. I can't think what it is now, but this alternating current enables. The thing about alternating current, do you know what happens when a power plant, you know when a power plant produces electricity? Okay, you have the big power plant. It sends out one strength of electricity along the line. So you have the big power, like the big power lines. That's coming straight from the power plant. With the alternating current, you step down. You have to step down to reduce the strength of the current for the machines. For example, if I hook this machine up or that machine up the currents that comes out of directly out of a power plant would blow the machine up. It has to be reduced, so the power that comes out of there is stepped down. So it has to be stepped, so the alternating current allows that to be stepped down. And also it facilitates the long distance transmission of electricity. It was in this decade the electric unit drive became the most common form of driving machinery, and electric utilities became the principal power for manufacturing. So your power plants increase, your electric unit drives get smaller, increase in, and I think for example, like the increase in cloud computing, so the network increases, but the computers get smaller. Network increases, computer gets smaller. In this era, the power plants increase in size, and the machine and the electric motors and the manufacturing gets smaller and smaller. So you can see there's a similar kind of process, and that's a point that I want to make, because one of the things that does is that gives us let me collect my thoughts here. Let me just think about this for a moment. Just get that. Let's see. The thing is that we can see these changes, and you can see how people got excited, because I was around in the 1980s, and by the early and I had the first like internet when I was in graduate school. I had I was able to do some computing online. We had a very early form of the internet, and then they had some very early internet in 1991, where you could get on. There was online. You could get some basic information. It was very exciting. It was very exciting. So you thought, and then of course in the 1990s, the very rapid development of the browser. So in the 1990s, the development of the browser, and it just seemed like, wow, it was all happening. The same thing, people seeing these changes, and they're thinking, it's going to happen right now. It's all going to happen right now. It's all going to be the advantages. And that really took place in that era, by 1920. That's the thing, is by 1920, then people began to see this. Very similar to by 1990, people began to see what was going to happen with computers. But still, let's go back just a little bit. Again, in terms of, I want to talk about factors that delayed. There's still these factors that delay the switch, the switch to these technologies. Electrical lighting, only 3% of households use electrical lighting in 1899. Only 3%. Only 8% in urban dwellings. So say even a city like, say, New York, 1899, most people don't have electricity. Still, most people don't. They don't have electric lights. As I said, the use of electric motors by 1920 it took over. Utility or electricity was still expensive, and as I mentioned, the thing was, when you have the old technology, it takes time to replace replace that. And the thing is that it takes time for people to learn. It takes time for people to learn how to use new technology. So that brings us to the impact of technology on stock prices. me check the time here. Because I may end up going back. I may go back to. It's 12:50. We have until 12:30. So I have 15 minutes. Okay, we're fine. We're fine with the time. And so what I want to talk about now is whether the swings in the stock market during the 1920s were driven by the diffusion of new technologies or periods of irrational exuberance. This is a very important question because people, economists have argued about this for a long time. I think that until very recently, economists in recent decades were thinking it was just something crazy. People just kind of went crazy in the way they were thinking. But in fact, that the people at the time saw these technologies, and so they really thought that these technologies were going to very quickly enhance production, and that the world was ready, that it was going to happen very quickly. This was why, in 1929, this is a very famous forecast, Irving Fisher. He was a very well-known economist, and he forecast the stock market. Let me show you the stock market here. This was the Dow Industrial Index in the 1920s, and this was the era of the stock market boom, which really began about 1924. So now we've seen how the electricity was by 1920 had overtook the steam engine. Remember that, about 1920. So now the market is looking at this and they're saying, oh, okay, oh, something's happening. Something's happening, we're seeing this, and then by 1927, it starts getting crazy. 1929, Irving Fisher, right here, peak of the market, it's gone up 3.5 times. So 450%, doubling 100%, 250%. So 250% increase, 3.5 times increase in, and this is in the Dow Industrials. And what I've done here is I've normalized it at 100 and I adjusted for inflation. So this is real change. This was the real, so adjusted for inflation. So this is real change in stock market prices. And the Dow Industrials, those are 30 stocks. The Dow Industrials are 30 major companies that go into making up the index. That changes over time, and that index has existed since the late 19th century. But in the but the mix of companies changes over time. The mix of companies in the Dow Industrials was basically, they were what we would call technology companies. They were companies that were using the new electric technology in the 1920s. So that's an important thing. That's an important thing to remember. So we'll go back here. We'll go back to this, and I'm going to talk about a study that was done. Let me just have a seat here. As I say, in 1929, the economist Irving Fisher forecast that stock prices, he said they were going to make, at the peak, he said they would remain permanently higher due to new technologies and advances in managerial organization because of the use of electricity. So electricity is now changing the way manufacturing takes place, new technologies, the profits are going to be increasing. These high prices are real. 1999, people said the same thing. That was the peak of the market. And we'll see that later. We'll talk about that, but I'm telling you a little bit of that story in advance. So 1929, people thought, this is great, it's going to last, it's forever. it's forever. So now we're going to look at a study, and I'll send you, I'll give you a paper to read. It's a very interesting paper where it talks about the growth of what's called intangible capital of firms in the 1908 to 1929 period. So this is the period, increasing use of electricity, increasing use of electric drive, decreasing use of steam and line shaft. The line shaft is fading away. Electric drive is increasing. So the question what this paper asks, did a technological revolution, did this revolution in technology lead to higher stock market valuation? And so the paper asks whether movements in stock prices are correlated with intangible assets of firms. And by intangible assets, what we're talking about are the human capital in a firm, the relationship capital in a firm. A firm has relationships, they have a reputation, they have a brand, a reputation, they have relationships. That's what we call goodwill. You know, as you know, relationships are very important in business. It's very important in this country. It's very important in terms of what we call an intangible asset. And structural capital, that's recorded knowledge, processes, software, intellectual property. Software, of course, comes later. But the idea is that this is what people know. So you have capital, you have machinery, but the machinery only has value because people use it. People make use of it. They use their minds to use the machinery. All of this knowledge is called intangible assets. So the paper is going to look.
So is it good thing that stock prices remain higher or?
Well, here's and what we'll show. What we'll show is that the way intellectual property and this was the use of patents, and this is it's the use of patent, and this is a study. I talked also about. Did I talk about patents? I talked about patents last semester, didn't I?
What patent?
Patent. Do you know what a patent is? Yes, this is very, very important. A patent, P-A-T-E-N-T, a patent is a protection. It's a protection for an invention.
Ah, yes.
Yes.
Tokyo. In Japanese.
Tokyo?
Tokyo.
Tokyo?
Tokyo.
Tokyo.
Like to protect the owner of something.
Yes, yes. That's right. So the patent, the protection. So that's the patent. If a company has a patent, that tells us the talent that they have. That tells us the knowledge that the company has. So the talent, the knowledge, the experience, the patent, because it takes, in order to create a patent, you have to invent. So that you have to innovate. And so what the paper does is it looked at firms, major firms in the 1908 to 1929 period. Very interesting paper. Because it, as I say, it looks at the, you had major firms that were using, these are major manufacturers, firms that were growing, that were becoming great companies in that era. And this author of this paper looked at about 20,000 patents that were issued in the United States, and one of the interesting things that was noted was that what patents do, you can tell an invention is important if later people note the invention later in a future patent application. So say I make a patent application in 1920. So I get a patent in 1920. And let's say in 1970 and say 1980, I'm making a new invention. And when I make a new invention, I have to talk about previous inventions that inspired that invention. So I have to say, when you make a patent application, you have to say, where does your invention come from? What other inventions did you use? Did you use other inventions? And that's part of documenting a patent. So what this paper looked at, where patents were cited, say, so 20,000 patents, 4,000 of these patents were cited in the 1976 to 2002 period in patent applications. That means that even 70 years later, these patents were still important, that these inventions were still considered important, that they were important. So this tells you that citing in future patents tells you how important. It's like, imagine that there's, let's say like if a song is important, someone later copies it, and they copy it, and it's called. So if they use elements of the song, and what they're doing is they're saying that was an important song. Well, this is the same way. The citing of the patent in a future patent application will say how important a patent, an invention that was made much earlier. So that's what this author did. They looked at, and they found that in about a third of these patents were actually cited more than once in patent applications. So he said, okay, they get cited. Some of them are cited more than once. And that's noted that most patents are not cited a decade after the initial granting of the patent. In other words, they're not really important inventions. So the citing of patents granted in the 1908 to 1929 period, which was a very important period of innovation, very, very important period of innovation in electricity. Decades later, a clear indication of the long-lasting technological importance of initial patents. So the paper, and I'll send this paper to you, it attempts to measure the correlation between the market's perception of the firm's value and patent applications. So the idea here is the market knows, because when a company gets a patent application, when they receive the patent, they said, we got this patent. They told the market, they said, we've got this patent. The market said, wow, that's a great invention. Did that, and so this paper says, did that increase the value of the stock? Did these announcements that the firms made when receiving the patents and the market learning about the patent, did they say, oh, that makes the company more valuable, we're going to bid up the value, increase the value of the stock, of the company?
Oh, that's why the stock price remains high.
Right. The same thing happened in the 1990s. Companies would make announcements of new technologies, new advancements, and the stock would go up by 20%. Very, very similar thing. So in the 1920s, the market is saying, wow, these technologies are ready to take over the world now, right now. And so these companies are making these announcements, the market's getting more and more excited, the prices are going up. And everybody thinks this is great. So the perception of the firm's value, the market's perception, and so he's using this to say what were the really important ones. What were the really important ones? And can the market tell could the market tell at the time which ones were really important? And that's also very interesting. Can the market see whether that's important? And so that's the, and I'll send the paper to you because he finds that that's a correlation. He finds that there was definitely a relationship that as the companies were making these announcements, the major companies were making these announcements, and especially from this period, from 1924. After 1924, there was a real pickup, real increase. And the corresponding year in the 1990s was 1994. The first browser was introduced in 1994. The market started going up. But we'll see that later. That's the later part of the story. But that's, so he correlates these stock market movements, especially this is the market, the bull market of the 1920s starts in 1924. Oh, 1929, it goes.
Is it stock price?
Yes, this is the price. This is the index. So this is, and as I say, that's adjusted for inflation. So this is real stock price. So this is the real price. So what we're going to show, in fact, what happened. We'll go next. That's what happened. That's what happened in the 1930s. That was 1929. That was the peak, and the market collapsed, and that was the start of the Great Depression. So we'll get to that. That's what we'll get to next week. And for those people that weren't here, I understand why you're not here, and you'll be able to watch this lecture. I'll be uploading. You'll see this tomorrow. It'll be up. Well, you don't know it because you won't see it until tomorrow. But it will be up tomorrow. I'll put it up tomorrow morning.
It must be terrible train delay.
Sorry?
It must be like terrible train delay.
Yeah, that's. I